in kilojoule per mole, and the electron gain enthalpy in kilojoule per mole of a few elements are given below. So we have few elements, 1, 2, 3, 4, 5, 6 elements we have, and they have given us the first ionization enthalpy, second ionization enthalpy, and this is electron gain enthalpy. And then they have asked a series of questions. Okay, I can't. Let me just, okay. And they've asked a series of questions. For example, the least reactive element, the most reactive metal, the most reactive non-metal, the least reactive non-metal, and the metal which can form stable binary halide of the formula MX2, the metal which can form a predominantly stable covalent halide of the formula MX. So you have to identify which of these elements are in these options A, B, C, D, E, and F. Now let us put some things in perspective. First of all, what is a metal? So metal, it has tendency to lose electron. And what is a non-metal? Non-metal will have tendency to gain electron. Okay. Now we can further understand this in the terms of electron gain enthalpy and ionization enthalpy. Okay. So if a metal has a tendency to lose electron, that means it will easily lose electron and its delta H ionization enthalpy will be low. Okay. Non-metal has a tendency to gain electron. That means their electron gain enthalpy, delta H Eg, this will be highly negative. This will be highly negative. That means they are very happy to accept electrons. And similarly, metal has tendency to lose electron. That means their ionization enthalpy will be pretty low. Is this clear, all of you? Please tell me, guys, yes or no?
Yes, sir.
Yes. Now there are only two types of compounds. We can differentiate things into two types: metals and non-metals. Okay. So the ones which are having high tendency to lose electron, they will act as metal. That means they will do reactions as that of metal. And non-metal will gain electron and they will show reaction as that of what? Non-metal. And the elements which have elements with delta H ionization enthalpy very high and delta H Eg may be positive or very less negative. That means they don't want to lose electron and they also don't want to gain electron. That means they are not reactive. So these type of elements will be not reactive. Are the 3 points very clear? Yes or no? Please tell me, guys. Alia, Martin, Yasser, Siddika, and Harsha.
Yes.
Yes. Okay, fine. Now let us look at the different elements. And whenever we say na high and low, so that should be put in perspective. Okay, you have to compare things and all. So first of all, let us see the element number 1, and we will first of all just look at it and then understand what's happening. So if I look at the first ionization enthalpy, this is the first ionization enthalpy. This is second ionization enthalpy, and this is electron gain enthalpy. So if I look at the first ionization enthalpy, it's very low. Okay, so it can lose first electron very easily, quite easily. It can lose first electron, and delta H second ionization enthalpy is very high. That means it does not want to lose the second electron. So I will write easily loses. One electron. And as you can see, the electron gain enthalpy is not very high. It's quite low. It's not very high. It's minus 60 only. Okay, so not very highly negative. Let us look at the second one. So second one has approximately similar type of first ionization enthalpy, similar type of first ionization enthalpy, but it has relatively low second ionization enthalpy, right? It has relatively, if this was 7,300, and this is almost half of it, right? It is almost half of it. So I will say that it can lose two electrons. It can lose what? It can lose 2 electrons. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, let us look at the next part here. If I talk about its electron gain enthalpy, again, it is not very high. It's quite low only. But as you can see, the first ionization enthalpy is quite low here. 419, this is lowest. Can lose second electron and lowest delta Hi. I can write first. At least these two things I can write. Now let us look at the third case. In this, we have pretty high. Here we have pretty high first ionization enthalpy, second ionization enthalpy is also. Now, if I compare here, the second ionization enthalpy is not very much. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Right? Okay. And other thing that you can see is it has the largest electron gain enthalpy. No one is having electron gain enthalpy as high as. So basically, it may be a non-metal, right? It will be non-metal and not a metal. So most probably it is a non-metal. Okay. Now, when I look at the fourth element, it is having almost okay first ionization enthalpy, quite low second ionization enthalpy, and this is again quite very high. It's again quite very high. Next, when I look at the fifth element, it is having high first ionization enthalpy. Second ionization enthalpy is also very high. Electron gain enthalpy is also positive. That means it neither wants to lose electron nor it wants to gain electron. So it is basically not reactive. Okay. Now, when I look at the sixth one, the sixth element is quite interesting. I think sixth element is the one which can easily lose 2 electrons because its second ionization enthalpy is the lowest. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Right. Now, with this information, we are going to write some answers here. We are going to write some answers. Now, which is the least reactive element here? Tell me, guys. Least reactive will be which one?
Yes.
Fifth one, right? Least reactive. Least reactive को मतलब क्या हुआ? Least reactive will have delta Hi is also very high, and delta Heg, electron gain enthalpy, is what it is positive. So which element is that? This is the fifth element. Okay. Most reactive metal. So when they are asking about metal, then I have to look at the ionization enthalpy, and it should be what? It should be quite low. So which of the following has the least ionization enthalpy? I think this is the second one which is having the least ionization enthalpy. Correct, guys? Yes or no? Please tell me.
Yes, sir.
I can write that. This is delta Hi should be less, and the least one is for second one. The most reactive non-metal. That means delta Heg should be highly negative. She's having the highly negative delta Heg, that is third one, correct?
Yes.
Okay. Now let us look at the next one, the least reactive non-metal. So it is a non-metal. It is a non-metal, but it is having what? Very low electron gain enthalpy. It will be having very low. It is not a metal, but first of all, please understand that it is not a metal. Okay. So all of these things, for example, minus 60, minus 48, we cannot consider them because they have quite metallic character because they have low ionization enthalpy, right? Here also low ionization enthalpy. So fourth one is a non-metal, but it is what it is, not very reactive. So we'll take this as fourth one. It should be a non-metal. How to see non-metal? That it is having negative electron gain enthalpy, and it's quite negative. It's not very less negative. It's highly negative electron gain enthalpy, but it is not the most reactive. It's the least reactive. है ना? हमारे पास दो ही non-metal है. These are the two non-metals that we have. Now this is interesting. Metal which can form stable binary halide with the formula of mx2. With the formula mx2. Now please see. Yesterday we did some exercise on writing the formula of a compound. So if something is mx2, that means m's valency should be 2 and the valency of x is always 1 because halogen has the valency 1, and then only they can make a formula which is equal to mx2. That means they're asking for a metal whose valency is +2 or which is easily losing 2 electrons. So which is that one? This is the sixth one, which easily loses what? 2 electrons because it is having. So what they're asking, first of all, इसमें समझ लीजिए एलिमेंट with least second ionization enthalpy they're asking. That is why now they can make binary halides so that their valency is 2. So which is having the least second ionization enthalpy, that is the sixth element. The metal which can predominantly stable covalent halide of the formula mx. Now, if you want to form mx, then there is only one choice that is left, that you have the first one, the number one element, right? Number one element, why? Because it is predominantly, they are saying that. What they are saying? Predominantly. But if you talk about the second element, बहुत सारे लोगों को लगा सर second element भी हो सकता है, but please understand, second element also has quite low second ionization enthalpy. Okay, so it can also make mx2 type of thing. But if I look at the first element, it is having quite low first ionization enthalpy, and its second ionization enthalpy is very high. That means it cannot make mx2. It will always make mx. But in the second element, the element number 2, it has some probability of making mx2. That is why when they are asking predominantly, then I will say the first one. Please write this down, guys. Let me know if you have any doubt. Please let me know once you're done, guys. हाँ बस ABCD लिख के write these questions and then write the answers. Metal 1, metal 2, and so on. There, everyone?
1 second, sir.
Okay.
Done, sir.
Okay. Now write the next part of valency. Okay, so what is valency? Valency, it is generally said as it is the combining capacity of an element. Okay, so you must know that carbon makes how many bonds? Carbon makes 4 bonds, right? So valency of carbon is going to be 4. Similarly, nitrogen can make only 3 bonds. Oxygen can make only 2 bonds, right? And fluorine can make only 1 bond. Fluorine can make only 1 bond. So the valency understanding of what is the combining capacity? So there are 2 concepts, old concept and new concept. So first of all, let us look at the old concept. The old concept of valency, it talks about the combining capacity with respect to hydrogen or with respect to oxygen. Okay, so what is valency? First is valency with respect to hydrogen, and the other one is valency with respect to oxygen. Okay, so for example, if you have sodium hydride, that means sodium can attach only with 1 hydrogen. That means valency of sodium will be equal to 1. But in that case, if I take Mg and Mg attaches with 2 hydrogen for making magnesium hydride, then the valency of Mg is equal to 2. You know? Similarly, if you take aluminium, so the valency of aluminium is 3. If you talk about carbon, so CH4 hota hai, right? So its valency is going to be 4 and so on. Okay. So talk about, let's suppose HCl you have. HCl it is attaching how many hydrogens? Only 1. So its valency of hydrogen is what? It is, sorry, valency of chlorine is equal to how much? 1. Okay, now valency with respect to oxygen, what does it mean? It is again, it has a bit of formula, but again, almost the same thing. Valency of an element is twice the number of atoms attached to element. So if you talk about sodium oxide, so sodium oxide is Na2O. So each sodium atom is attached with how many oxygen? 1 oxygen. Each sodium atom is attached with how many oxygen? 1 oxygen, right? So I can say both of these are attached to 1 oxygen. That means each is attached to half, I can say, right? In the compound, I have one oxygen. So each sodium is attached with how much? Half. So valency will be equal to 2 into half. Okay, so which will be equal to how much? 1. Similarly, if you take MgO, so MgO valency will be now what? 2 into how many oxygen atom to each element? 1. So this will be 2. If you take Al2O3, suppose you have Al2O3. In this case, if you talk about the valency, then as you can see, 2 multiplied by each oxygen atom is shared. Now, 3 oxygen atom is shared by how much? 3 oxygen atom is shared by 2 aluminium. So I will write 3 by 2. So which will be equal to how much? 3. If you talk about carbon, so carbon dioxide. Valency is equal to how much? Valency I can write as how much, tell me guys? 2 into 2 oxygen atom, that will be equal to 4. So only if you understood the valency, the concept old and new with respect to hydrogen and oxygen, yes or no, please tell me.
Yes, sir. Yes,
Okay.
sir.
Next is the, so please write this down if you have not written. Let me know once you're done. Is everyone done? Yes or no, please tell me.
Yes, sir.
Now, let us see the new concept, the modern concept. Okay. So modern concept, it talks about the valency with respect to the groups that we have. Okay, with respect to the groups we have. So we are only going to talk from group 1 and 1, 2, and then I will talk about 13, 14, 15, 16, 17, and 18. Okay. So group number 1, 2, 13, 14, 15, 16, 17, and 18. Okay. Now, if you look at some IUPAC periodic tables, then for 1, you must see something like this. You may see, rather than 1, they will write 1A, they will write 2A. For 13, they will write 3A. For 14, they will write 4A, 5A, 6A, 7A, and for this, they will write 0. Okay, so this is 0 group. Okay, all right, 0 here. And this is basically the 18th group. Now, as we all know, the outermost electronic configuration for the first group is what? It is NS1. Similarly, for second, it is NS2. For third, it is NS2 NP1. For fourth, it is what? NS2 NP2. NS2 NP3. Here you have NS2 NP4, NS2 NP5, and NS2 NP6. Okay. Now, the number of valence electron, if I talk about the number of valence electron that we have here, we have 1 electron. Sorry. If I talk about the valence electron, then here we have 1 electron, here we have 2 electron, 3, 4, 5, 6, 7, and 8 valence electrons. If I talk about the valency, I need some space. Okay, so if I talk about valency, then this will be 1, 2, 3, 4. Now here, if you can write, here you can have two valencies. Here you can have 5 as well as 8 minus 5, which will be equal to what? 3. So you can have 3 and 5. Here you can have what? Here you can have 2 as well as 6. Here you can have 1 as well as 7. And here you will not have anything. You'll have either 0 or 8. Okay. You'll either have 0 or 8. What does that mean? The first, second, third, and fourth, they can only have valency 1, 2, 3, and 4. That means they cannot exceed this valency. But if I talk about 5, 6, 7, 8, and so on, they can have valency 3 and 3 to 5, not more than 5. Similarly, the 16 group element, they will have valency from 2 to 6, not more than 6. Similarly, 17, the halogen will have 1 to 7, not more than 7. Okay, not more than 7. Is that clear? Yes or no? Please tell me, guys.
Yes, sir. Yes, sir.
Okay, so please write this down. Let me know once you're done.
Done, sir.
All of you done? Yes or no? Please tell me.
Yes, sir. Yes, sir, done.
Okay, fine. So this was almost the last topic for this chapter, and everything else we have already almost covered. I mean, you can start talking from this, starting with the periodic trends and then the chemical reactivity. We also talked, we have given some hints, you can say, right? For example, when we talk about the periodic trends, about whenever I say delta ionization enthalpy, what should come in your brain? Metallics, right? Metals. Whenever I talk about delta EGE, then what should come in your brain? Non-metals, right? Okay. So with the elements which are having high ionization enthalpy, they are not metals. Which are having low ionization enthalpy, they are metals. And the electron gain enthalpy for who the elements which have high negative electron gain enthalpy, these are non-metals. And then what happens? These type of elements, they show reactions. अब यहीं पे क्या होता है? This is the path that you are going to take in order to understand the next chapter. For example, if you have a metal sodium, right? So how do we see something is ionic or something is covalent, right? So यही है बात यहाँ पे कि when you have sodium chloride is what it is? Completely ionic in nature. But if I talk about, let us suppose if you have CCl4, and here sodium, when it is attached with chlorine, it is ionic. But when carbon is attaching with chlorine, it is covalent. How is that possible? So that is only possible because here we have two different elements and their properties are different. If I talk about sodium, then sodium in this part, it is having low ionization enthalpy, and chlorine, it is having high negative electron gain enthalpy. So sodium, it wants to lose an electron, and chlorine, it wants to gain an electron. And that is why sodium, when it gives one electron to chlorine, when there is electron transfer from sodium to chlorine, then we can say that bond formation takes place. Or rather, what we will say, sodium is not going to give electron on its own. Please remember that also. If you put sodium on its own, sodium is not कि वो ऐसे बिल्कुल हमारे की तरह इलेक्ट्रॉन की बौछार कर दे रहा है ना, इलेक्ट्रॉन ऐसा नहीं हो, ठीक है? Sodium will give electron only in the presence of a chlorine, only in the presence of a bromine. That means if there is someone who is accepting electrons, then only sodium will give the electron. Okay, so these are the concepts that you have to be very clear of. Also, there are some people who will say that, for example, if I ask, what about sodium and sodium positive, which is more stable? No, so they talk in these terms. They will say, okay, fine, the electronic configuration for sodium is 2, 8, and 1, which is not a noble gas configuration, but for sodium positive, it is 2, 8. That is why it is possible. I will say no. Sodium positive is not more stable than sodium. Why? Because it has a charge, and anything which has charge cannot be more stable. But if somebody asks, what is more stable, sodium or NaCl? Now, this is it's completely different question now, because when I am talking about sodium, then I only talk about sodium. But when I have sodium chloride, the positive charge on this sodium atom is neutralized by the chlorine negative. And that is why these are quite not, these are very stable. And how can you talk about the stability? You can Google anywhere, sodium plus water, it will show explosive reactions. Maybe you have done this reaction also, maybe you heard about this reaction. Sodium, if you drop it in water, it reacts very abruptly. And how easily do we mix sodium chloride? Nothing happens. That means it is not very reactive. Okay, so it's a stable compound. But sodium positive is not stable. Please understand that. Sodium positive is only stable when it is in the presence of chlorine negative. If it is on its own, it is not very stable. It's unstable. Okay, so we are going to talk about these things in more detail in the next chapter, that is chemical bonding. And we are mainly going to talk about the covalent compounds. Ionic compounds do not have much into it. We are mostly going to talk about covalent compounds and ionic compounds. Now, before going there, I want you guys to have a discussion on Fajan's rule. And this is something that you should have a bit of idea, not because it is going to be asked in your examination or something like that, but you should have an idea about Fajan's rule. Okay, so what does Fajan's rule tells about? Please write that. It talks about covalent character in ionic compounds. Okay. So first of all, we have to understand what is meant by covalent and what is meant by ionic. And okay, if there is some covalent character in ionic compounds, that means it is not a very binary kind of thing, that covalent and ionic. It is rather a kind of, you can say that some covalency is present in ionic compounds and some ionic character can be also present in covalent compounds. But Fajan's rule, it only talks about covalent character in ionic compounds. So in Fajan's rule, we will never look at covalent molecule. Please understand that. We are never going to look at covalent molecules. That means the molecules which are made by non-metals. We are never going to look at them. We are going to look at the compounds which are made by metal and non-metal, by the combination of metal and non-metal. That means predominantly ionic. Now, first of all, let us understand what is covalent and ionic. So what is ionic? So ionic basically is when you have a metal, it gives electron to non-metal. Okay. So once an ionic compound is formed, this metal will gain a positive charge, a complete positive charge, and the non-metal will gain a negative charge, a complete negative charge. Okay. Now, the only part, now what is covalent? Understanding of covalent is more important here. Covalent compounds, if I talk about covalent compound, then they share electron pair. For example, I have A and B and they have a bond between them. So A and B, they share electron. So if I look at the nuclei of A and B, then it will be something like this. You have positively charged A atom nuclei, B is also positively charged. These are the nucleus, and there is an electron density here. Okay. Now, obviously, positive charge will repel each other, but because of electron density between them, what happens? This positively charged A nucleus, it is forced in the rightward direction, and the B nucleus is forced towards the leftward direction, and that is why they are combining and they are forming bond. Now, what is very crystal clear between ionic and covalent? The difference is very clear. There is no electron density between the ions here, but there is electron density between the atoms in the covalent molecule. Is this clear? Yes or no? Please tell me. There is no electron here, and there is electron. भर के electron है atom A or atom B के बीच में. Is this clear? Alia, Martin, Yasir, and Siddika, all of you guys?
Yes, sir. Yes, sir.
Okay. Now, if we have ionic compound, I'm just saying, if we have ionic compound and it has some electron density between these two ions, then we will say, okay, fine, it is having a bit of electron density. Now you guys tell me, first of all, if I look at a cation and an anion, here we have cation, here we have anion. Which is having more electron, cation or anion? Tell me, guys, which is having more electron, cation or anion?
Anion.
Anion is having. Very good. That means if there is any electron density between these two ions, it will be coming from the anion only. Though that electron density can come from the anion only. That can come from the anion only. Now tell me, which of the anions can lose the electron density easily? If I have a very small anion and it is very concentrated and it is very heavily surrounded by it is heavily attracted by the nucleus, and then we have a very large anion. That means the electrons are very far away from the nucleus. Electrons are very far away from the nucleus. So tell me, which case is which can give easily electron? Which can easily give electron, A case or B case?
B.
B case, right? Alia, what did you say?
B case.
B case, right? B case, because if I have something very large, it can be we can pull easily from there because nucleus is very far away. Now, who is going to pull? Who is going to pull? The cation is going to pull. Now tell me, which has more pulling power? Which has more pulling power? A cation which is very large, not at all focused, right? To attract something, you should have focus. If you don't have focus, you cannot attract effectively. And there is a cation which is very small in size, which can focus effectively and it can pull the electron density towards itself. Tell me, A or B?
B.
B case, right? And that is why when you have a very large anion and a very small cation, look what happens. This is an anion. Now this anion's electron density is here, and this electron density is pulled by only small positive charge. So all the electron density are pulled like this. Right? So some electron density, it comes in between. And there is a bit of covalent nature that is coming inside this compound. Although it is ionic, there is some covalent nature. Why it is happening? So I can write what does Fajan said. Fajan said that covalent character. Please remember, he is only talking about ionic compounds. Okay. So first we'll have to establish that it is an ionic compound. Then we can talk about percentage covalent character. Na? How much covalent character is there? So covalent character, it is directly proportional to the size of an ion and inversely proportional to the size of cation. यहाँ लिख देते हैं बार बार covalent character in ionic molecule, in ionic compound. Okay, so this small thing is Fajan's rule. All of you understood this? Yes, some of you tell me.
Yes. Yes, sir.
Okay, very good. Please let me know once you're done writing.
Done, sir.
Done. All of you done?
Yes, sir.
Sir.